Hi, for this practical, I will briefly explain the concept of chemometric using principal component analysis or PCA and its application in an industrial distillation process. PCA is a data analysis technique used to reduce complex dataset with multiple variables into a smaller number of principal components that capture most of the variations. In industrial chemistry, PCA is commonly used for quality control and process monitoring. In this video, PCA was applied to distillations data involving temperature, reflux ratio, and ethanol concentrations. The script plot shows that the first two principal components explain most of the variance in the data. PC1 accounts for about 41% of the total variance, while PC2 explains about 32%. Together, they represent approximately 74% of the overall variations, indicating that two components are sufficient to describe the process. The Gradient plot shows that temperature contributes most strongly to PC1, indicating that temperature is the main factor influencing process variability. Ethanol concentrations contribute strongly to PC2, showing that it plays a major role in determining product purity. The reflux ratio has a smaller influence compared to the other variables. The biploid combines both the score and loading informations. The data points represent individual samples collected over time, while the arrows represents the process variables. The spreads of the samples indicates continuous variations in operating conditions rather than distinct clusters, reflecting normal fluctuations during the distillation process. In conclusion, PCA successfully simplified the multivariate distillation data and identified temperature as the most critical parameter affecting process stability, while ethanol concentration mainly influenced product purity. This demonstrates how chemometric techniques such as PCA help improve understanding and control of industrial process. That's all from me. Thank you.